How to be a blue teamer. There will be a couple parts that overlapped pretty heavily with what he just talked about, so we'll kind of skip over those because you don't want to hear them twice. So, quickly, who am I? That emoji changed, neat. My name is Logan Woolery, computer engineering student here at Iowa State, and I work for IASG, which are the wonderful people that put on these CDCs. So, what is a blue team? Today we're going to be discussing it in the context of the cyber defense competitions. However, blue team is just sort of a widely used phrase that in this context means sort of the defensive security people. These would be like the IT set guys at most companies. Let's see. So, in a CDC, you are given a scenario and a large number of VMs, usually somewhere between 3 and 10, depending on how much fun we've had. And generally, we tell you that they are sketchy for some reason or another, and if we don't tell you that, assume that they are. So where should you start? Well, the first thing is usually make up a nice network diagram, however we usually give you one. We'll come back to this one in a few slides, but just know that mapping out what all you have and what's talking to what is a good first step. So now that you're onto an actual box, update your things. Cole touched on this one. Out-of-date packages are bad. You should update them so you don't have them. Second thing, check out what processes you have running and who's running them. This will kind of tell you, like, say you have a web server running as root. That's a bad idea because now if I somehow break your web server, I can now start messing with things as root, which is frowned upon. Let's see, what else? Oh yes, cron tabs, those are fun. For those of you that don't know, cron tab is an automated process scheduler on Linux. You set it up to run scripts at XYZ interval. So there have been some fun ones in the past with, I wrote one a while back that would overwrite your source code with the base source code the morning of competition. So if you didn't check your cron jobs, your web app would just get reverted back to its vulnerable state at 7:55, which is fun. Bashrc, etc profile, these are both files that contain statements that are executed by your shell before you are given your shell. Most of the things in here are pretty benign, setting aliases so that LL works, setting up environmental parameters, the PS1 for your prompt, but you can also hide fun things in here like nc-l-p666-k-e bin bash, which will start a netcat listener that just serves bin bash to anyone who wants to go talk to it. That's a fun one. So after you've audited all of these, now you want to go and look at your users and groups. Etsy password, Etsy groups, these are where your users and their information are stored. File permissions are another big one. Just here it says /Etsy, but really you want to check your whole box. Anything that looks like it might be important, any web apps, databases, applications of any kind really, you want to check and make sure that those can't be modified. And then places like /user/Etsy that store either the executable files on your system or their configuration parameters. You don't generally want those world readable, writable, editable. So you want to check those obviously. So now we're going to do a quick little demo of just going through some of these steps. So let's just see if I can make this just a hair bigger. Come on, Chrome. Okay, it says no. I hope you all can read that. So what I'm on right now is the web app box from NCDC, which was our national cyber defense competition that happened, I don't know, 3 weeks ago, something like that. This is the web app box that all the teams were given. So what I have here is just a root shell. Let's just go to the home directory here. So just kind of going down that list that we had earlier, we can do ps-aux, put that into less so that it's readable. A lot of pretty normal stuff here, all the systemd nonsense. If we scroll down, we can see that, oops, my mouse won't show up on there. www data is running an Nginx server. That's not too unusual. ZSH running for root. Oh, if you go look at, what is that, the 5th line up from the bottom, root is running node/root/webapp/bin/dub. That is the JavaScript web app that I wrote for this competition. Since it's being run as root, if you manage to exploit that web app, which is pretty easy, you can go and you can actually just do arbitrary commands. So you would want to move that out of root's control. Actually, if you go ls here, let's see, yep, web app. So we can just do, and now you can see the source code for the web app is owned by root. Not a good idea, because now in order to be executed, you have to be root because it's owned by root. So you'd want to move this all off to say data or some other low privilege user. Probably not data because he already has perms for the Nginx box or Nginx server. But you know, web app is a good user to create. Speaking of users, let's go look and see what all we have. Actually, first let's do ls/home, CDC. There's a CDC user. He probably shouldn't exist, but you know, that's nice. But not every user actually has a directory in the home directory by default. So we're gonna go, I don't want that file yet. Etsy shadow. Ah, dang it. Vim remembered. Okay, so if this were an actual box you'd been given at the CDC, I would have cleared all the Vim history, but whoops, I didn't run my Ansible scripts against this. But this is your shadow file, which contains all your password hashes, user information. So you can see that there are some users in here, nobody_apt. If we scroll down to the bottom here, we'll see root, CDC, web app, right? But since I already spoiled this, this is not the bottom of the file. If you actually go way down to the bottom, you'll see that there's a user named Bob who has a password, and that password is CDC if anyone was curious. There is no reason for Bob to exist. Users in a CDC will always be laid out for you in the users document, which is mentioned in the scenario. You will also be able to find your users. Side note, if you just come over to iScore here and you go look at your TSI, we can see all of the users and the relevant information. For those of you who have competed before, yes, this page got upgraded very recently. But yes, we can see 9bunbuns, date of birth, and Alice Rabbit's password right here. So for this last competition, the Chris affiliates had a user named Alice Rabbit with the username 9bunbun and this password. Congrats, Chris affiliates, I'm leaking all your passwords now that it's over. So obviously Bob is not in that list, so we can just go ahead and we don't need Bob. See, now Bob doesn't exist. Bob can't log in. Speaking of logins, let's go look at Etsy password. Etsy password defines some information about your users. Specifically, the bits I'm interested in here are, this first bit is the username, in this case root, and we click past the name. We have their home directory, and we have their shell. So when this user logs in, they get user bin ZSH, and they start in /root, which is root's home directory. So if we look here, we can see a lot of people have user sbin no login as their shell. Should be a couple in here, yeah. MySQL has been false. We'll just scroll down. Oh, there's Bob again. We still don't want him. So that looks all well and good. But now we're gonna do a fun little trick, and we're gonna check and make sure that all of our packages are what they say they are. So we're gonna do debsums-s, which just means that it will only spit out if something is wrong. So we hit enter. This will take a few seconds. Actually, on this box, it'll take a very many seconds, so I'm actually gonna cancel it. What that's gonna do is it's gonna go through everything that's installed on this box, check its MD5 sum against a pre-calculated hash, and tell you if something has been changed. Changed, modified, rewritten, otherwise messed with. The reason that this is important right now is it would have told you, if I had let it run for 10 minutes, that bin false has been changed. So let's just see what happens if I do bin false here. I should have another shell. You can't tell because it's the same shell, but I am now 2 shells deep because bin false has been replaced with a link to bin bash. Which means even though that file said that everyone had bin false or bin no login, those were both actually pointing to bin bash, so they had shells. But debsums will also do like one of the boxes for this last comp had an evil version of OpenSSH installed on it, called Very OpenSSH, which looks exactly the same except for it just lets you log in with the password I am Groot. Which is fun. Debsums would have told you that, hey, this package isn't the real SSHD, maybe change that. So, let's see, debsums, users. There's a whole bunch of other things oh, yes, an important thing I forgot, almost. Always check your history file when you're given a new VM. This should have been the first thing I did. And you can see these are all my commands. Oh yeah, because I'm shellceptioned. Now we're back out of that bin false that's secretly bin bash into oh my ZSH. So if we go look at the history for this, there's a lot more, and it's a lot more interesting. Let's see. You can see I'm messing with some config files, messing with MOTD. You can see a lot of stuff playing around with SSHD, which is fun. You can see right there, line 102, where I just kind of disabled the GUI on this box. Let's see, playing with authorized key files so that more people can log in than they should be able to. I forgot how much stuff I left in here. Okay, well, I'm just gonna skip reading all of this. And we're just gonna do vim etc. This is in that history. I'm just too lazy to go that far. And down at the bottom here, I believe, npm set audit false, which is a fun little thing that means that npm, the node package manager that the web app uses, isn't going to audit packages for you. Normally it just checks every time you do an operation to see if you have any vulnerabilities for your packages. This disables it. So this goes back to editing your bashrc, bash profile, etc profile, etc. Because right now every user is having this run every time they open a shell, which is fun. Let's see. Anything else that I should show you real quick from those slides? I don't think so. There's a whole lot more that's wrong with this box. If you were in NCDC, I'm sure you found a lot more things that I left in here that either I've forgotten about or I just don't want to talk about because I want to reuse those vulnerabilities. But there are a lot of fun things you can do with that. Actually, we will do one thing. We will do a quick demo on why you should not run web apps as root. 10.0.102.124. Ta-da! No, I don't want to translate this page. So this is the web app. It was a Russian communist bank themed CDC. But for now, we're just going to do with an easy one. And you can see that I've already searched some things. But if we search for admin, we get a link to the admin page, which is quite helpful. I'm not logged in, so I can't see that yet. I wonder what happens if I search for that. Sure looks like an etc password file. Here's why you shouldn't run things as root. This was a pretty easy command injection vuln to exploit and to find, but very powerful, and they can be much harder to find and much more annoying. But since I'm running as root, I can see this file, and if I was so inclined, I could do, let's not break this too much. Echo hello everyone to the end of. Didn't find anything. But if we go cat it again, it didn't work. Oh, because that file is write protected. That's right, silly me.
No, it's at the end.
Is it? Oh, I forgot my new line. Okay, so I'm bad, but, and now, let's see. Charlie Dvorak Charlson can't log in anymore or something, because I broke that for him. Anyways, back to the pretty slides. So, proactive defenses. A lot of this stuff I didn't demo because this would require way more time than I have, and I doubt you guys want to sit here for 5 hours while I configure a full network. But just going down the list here, audit what needs to be public. The databases for this competition in particular did not support authentication for the database, so you should probably not make that publicly accessible. Open ports on systems. Let's see, there were a couple boxes that had netcat listeners where they shouldn't have. If you just went and checked with like netstat for what open ports you had, you could see that there's a netcat listener listening on port 666, which is not good. Firewalls and network segregation, yeah, they're the same words. Those two go hand in hand. The idea there is not everything on your network needs to be able to talk to everything else on your network, and not everyone on the open internet needs to talk to everything on your network. Using firewalls, you can effect network segregation, which will prevent things from talking to each other that shouldn't be, which will prevent pivoting, which is the process of an attacker moving from one compromised box to another. So for example, if I exploited that command injection to create myself a root level user on the web app box, the web app box had no need to be able to talk to, in this case, say, the ATM, right? It never needed to be able to go out to the ATM. So you could just firewall that off, and so I can't pivot from my compromised web app to your ATM. Let's see, LDAP we'll touch on a bit more in a second. Jailing, no exec. Different operating systems have different ways of doing this, but generally putting users in places and telling them they cannot go anywhere else is a good idea. It's pretty simple. Log monitoring and IDS we'll also touch on a little bit more at the end. General idea there is just know what's going on in your systems. So, back to that graph at the beginning. Let's see, I already said all this. Checking open ports, I talked about this as well. Here's a nice graph of actually using Nmap against your own boxes. So this is always a good idea, is just scan your own stuff and just kind of see what's open and whether it should be. In a CDC here at IASG, you are given an entire range of addresses, and those are your addresses, and anything on those is your responsibility. So doing a quick Nmap sweep of your entire network is not a bad idea, because sometimes we like to leave little things hidden there that you can't see in vCenter. So scanning is good. Firewalls. We already talked about this a little bit. There are two major kinds here. You have host-based and network-based. Host-based being a firewall that lives on each box and just says, I am allowing X traffic in and X traffic out. IP tables obviously is a very common one for Linux. Fail to ban usually works with IP tables so that you can ban people. And network-based would be like a pfSense or oh crap, there's a couple others. pfSense is the big free one, so it's what you see at the CDCs the most. And these sit, as you can see here, in front of all your servers and dictate what can even get to them from the open internet. Network segmentation. So this is where that graph that we looked at earlier kind of comes in mind. At the beginning, you could see that everything had a line to everything, more or less. Now, you can see that there's a firewall between the internet and your forward-facing servers. You can see that the only things accessible through that firewall are your VPN, your mail server, and your www box. You can no longer, from the open internet, get to the intranet, the FTP box, the database, or the backups box, because why on earth does Joe Schmo, your bank customer, need to be able to see what's on your backup box? He doesn't. But you can see that users here have a special VPN access to an intranet, which lets them talk to FTP servers. But the two most critical things, the database and the backups, which are what you'll use to recover if something goes terribly wrong, are only accessible from the admin network. The way you can do this stuff is VLANs, or we give you 10 DV switches, which basically emulate hardware switches. So you can set those up in such a way that it is physically impossible for two boxes. Say if we put VPN on DV1 and backups on DV2, you would not be able to talk to these two without something bridging that gap. User accounts. So this is another problem. In a CDC, we generally give you somewhere between 5 and 2,000 user accounts, I think is about, no. 2,500 is the most I've ever given to a set of teams. Obviously, it's not ideal to go to each box and type out their username and password to set them up. Beyond that, you also want to make sure that they have the right permissions, because we always ship several different roles, usually something to the effect of administrators, developers, end users, and they all need different permission, but they need the right permission. So the easy solution is just to create everyone's account and just give them root on everything, because then they'll always have the right permissions. That's a bad solution because that means they also have the wrong permissions. So the solution here is LDAP, usually. There are other centralized auth things out there, however, LDAP and specifically Windows Active Directory are the most common ones you'll find. This lets you do centralized auth with role-based or group-based, depending on your flavor of centralized auth, permissions. So I can say specify that Bob is in the developers group and he's in the users group, but he's not in the admins group, which means he can do developer or user things, but not admin things. This is very helpful because it means that I can specify that our friend Bob can go and say access the GitHub server and commit source code because he's a developer, but he's not an admin, so he can't go in and say install packages on a machine, because why would he need to? It also makes it very easy to do hiring and firing anomalies, which are a class of anomalies that we have where you are given a new user to add to your system or an existing user and they need to be removed from your systems. If you've done this all the manual way and you're just typing out usernames and passwords into command lines, these suck because you have to go to each box in the 15 to 20 minutes we give you, remove that user, make sure that they don't have any accounts lingering around. It's unpleasant. If you have LDAP or some other central auth, it's easy. You go to one place, you add them to the right roles, and they can log in where they need to be able to. A little hint for you guys, since you guys showed up to my wonderful talk. Starting this competition, well, for like 2 years now, hire fires have been auto-graded. So the minute the anomaly expires, iScore logs in with the right user. And if it's a hiring anomaly and they can't log in, you get no points. If it's a firing anomaly and they can log in, you get points. Starting this next competition at ISU 2, firing anomalies now have a new feature. I'm not going to tell you what it is, but I will tell you that the iScore docs are publicly accessible at docs.ish.org, and you're welcome to go find out what it is. So yes, there are new fun things happening with firing anomalies specifically. I love that I see people start Googling right away. So an IDS is more of a log monitoring type thing. There are a couple different flavors. Generally, the point of an IDS is to sit and monitor something and try to see if an intrusion has happened. IDS stands for Intrusion Detection System. There are a couple different kinds. There are some that live on your network, say at your firewall, and those sniff all the traffic that's going through. And if it sees anything that looks like a virus, sometimes it just raises a flag. Some of the more fancy ones will actually take that, put it in a VM, run it, and if nothing goes wrong, it gets passed on to the user. If something goes wrong, they burn it with fire. The other kind is more host-based monitoring. These tend to sit on a host, or more accurately have listeners sit on a host and monitor the log files, process files throughout the system, and just kind of keep track of what's happening. These will say, let you know if one of your log files reports a critical crash, or if some user is now trying to run an interpreter session, right? And then they'll let you know that these are happening without you having to go to each box and just watch the logs yourself effectively. So this one is not one I've used. This would be more of a host-based one, I believe, and it's just kind of mapping out where you've been attacked from. This doesn't really work in IASG CDCs because we steal IPs from the real internet. IASG runs a fake internet so that we can do cyber attacks safely. So if you use something like this, it'll tell you that you were attacked. However, the bit where it says from China is going to be wrong because China isn't real in our environment. China is some guy in the red team, probably named Tom. Snort is, I believe, a more IDS or network-based one. I think this is network. And it just checks the traffic and sees if there's anything suspicious looking. Let's see. So the last step that I would recommend after you're fairly confident that you have your stuff set up well, maybe do this like the day before competition if you're not one of the people setting up your network overnight, which is kind of a tradition, but red team yourself. Go see what's out there. You don't have to be particularly good. This is in a case where it's perfectly fine to be a bit of a script kiddie. Some vulnerability scanners are always a good place to start. Nessus Metasploit has its suite of scanners in the auxiliary folder. Those will just go out, scan your stuff, and look for vulnerabilities. And then if you're using Active Directory or a bunch of Windows stuff, Bloodhound, which has a tagline of like seven levels of domain admin or something, is a really good tool for checking if any of your users have the ability to become a domain admin. So these are all very, very noisy. If you're doing real red team, you don't want to use these. But in terms of just making sure that your stuff is really locked down before you start your competition, they're a great idea because who cares how much noise you make on your own systems. So last plug here, ISU 2 kickoff Wednesday, the 27th, which is tomorrow at 5:30 in Couver 3043. Which is the department conference room up on the 3rd floor, right next to the server room. So, with that, does anyone have any questions about anything? Doesn't have to be strictly related to what I talked about, just anything CDC related, anything securing a box related. Ask away. No? Cool, means I don't have to talk anymore. So, these, oh.
So, where would be a good starting point to using these boxes and learning how to go through them and blah, blah, blah? Like, using them, going through files and such. And
like just basic how to Linux, or I guess I'm not quite sure what you're asking.
I don't know, I'll just figure it out when I'm trying to
No,
cyber defense competition.
I'm happy to answer.
How do I, like, what exactly am I looking at? Like, I saw a bunch of code earlier on it, like, what's going on? I don't have anything specific, just like where's a good starting point to navigating the box that we're going to be given to work with?
So you'll get a scenario document, which will tell you what boxes you have and what services that they're required to have exposed.
Okay.
So this will kind of give you a rough outline of what each box is supposed to be. For example, that www box I demoed on earlier, the section for that was, here's a box, it's running a web server. It needs to have HTTP on port 80, and it needs to have SSH on port 22. So you start there and you say, okay, well, where's my web app source code? And you go and find that, and you say, who's this running as? You say it's root. Okay, I'll change that. Beyond that, as far as more specifics of how to navigate each box, infer from the scenario, and then don't be afraid to go out and experiment. You have the ability to make snapshots. So a good first step is always just make a snapshot as soon as you get your VMs. That has saved a lot of teams bacon a lot of times. Cole here is nodding because he's used it. Other than that, just explore. Feel free to ask questions. These slides will be up and available, and if you want to go read through them, they have more detailed information on the steps. And then there are all these links that are pointing to different things.
We're gonna find that slideshow.
I'll link it in Slack later.
Okay.
In the back.
So you said we should use dev sums to see if you've messed with binaries on the system. How do we know if you've messed with dev sums?
You install that yourself. apt purge debsums, apt install debsums. You could also just try purging and reinstalling everything on your system, but like, there's a pretty good odd that you'll just break everything if you try that approach.
How do we know you haven't messed with apt?
Figure it out yourself. Manually take the sum. You can actually just manually take the SHA sum of the package and then compare it to what apt has on their official website. Okay, anything else? Excellent. Thank you all. I hope that I will see you all tomorrow at 5:30 in Cooper 3043.